In lesson 2 of labor market equilibrium 4B, we're going to look at the effects of subsidies that are given to either employees or employers. So in order to do that, we have to open up this Desmos worksheet, this Desmos model, by clicking on that. And then we need to set the parameters of the model according to what we're given in our version of the model, right? My version of the model is going to be different than yours, right? Now, this right here is the labor demand equation, and it's this downward sloping line. And we know this is the labor demand equation because there's a negative sign here, and that creates a negative relationship between employment level and wages. So when wages go up, firms generally demand less and less labor, right? If wages are high, they'll demand very little labor. If wages are really, really low, they might demand more labor. So that builds this negative relationship that we call labor demand. And this over here is a labor supply curve, because what that models, it models the heterogeneity of the people in this labor market. Some people in the labor market are, they have lots of experience, they have incredible, timely, productivity enhancing skills. They might not have lots of kids. So those kinds of people might have higher reservation wages, whereas somebody brand new who has lots of kids, very little education, very little applicable training, they might be more desperate for work and their reservation wage might be lower, right? And so what the labor supply curve captures is this heterogeneity in the workers in a labor market, where each is placed in a line according to their reservation wages, right? The first person hired, right? The first person in line for the job is going to be the most desperate. They're going to have a very low reservation wage, whereas the last person in line is going to have a very high reservation wage. And so if the wage is not equal to this value for that person, they're going to choose not to work in this labor market, right? Whereas this person down here, the reservation wage is really, really low. They're going to work in this labor market because the market wage is going to be greater than their reservation wage, right? So let's go ahead and insert the parameters of our model over here. The demand slope in my model is 0.22. The demand intercept in my model is 21. The slope of the supply curve is 0.78. And the supply intercept is 3.5. I'm going to blow this up just a little bit. Zoom it in. I'm also going to get rid of the tax. I'm going to set the tax on suppliers, or the subsidy on suppliers, equal to 0. And I'm going to set the tax and subsidy on demanders equal to 0. Demanders are the firms, right? They demand labor. And the suppliers of labor are workers, right? Workers who are looking for work in this labor market, right? Okay, so let's answer the questions. The green line is our labor supply curve, and it's upward sloping. The downward sloping red line is our demand curve, and it models, or it is reflected by this downward sloping line in my open math, right? So that's labor demand. And this is labor demand in Desmos. It's the same exact graph. This is the labor supply curve, which is represented here as that curve, right? This value here, this axis here, is the wage rate axis, right? The y-axis. This axis here is the employment level, or the x-axis, right? So the employment level is x, y is w, right? And we find the equilibrium employment level at the intersection of the two, right? We find that at the intersection of the two. So the equilibrium value here, the equilibrium level of employment here is 17.5, right? The first number is the employment level. The second number is the wage rate. So if the employment level is in terms of thousands or millions, right? Say it's in terms of millions, it's a large economy. this would be 17.5 million, right? And then this over here would be $17.15, $17.15 per hour. So this is in dollars per hour. And this would be perhaps in millions, right? Millions of people, right? So the employment level is that first number, 17.5. And again, it could be 17.5 million, right? There's a lot of low-skilled workers in the United States economy, right? The marginal firm is willing to pay. Now, the marginal firm here is the firm that probably has a higher cost structure than other firms hiring in this labor market, right? It's marginal firm. And it hires the last worker, right? And it's willing to pay up to $17.15 per hour, because that's the value of the height. That's the height on this labor demand curve at this employment level of 17.5, right? So the most is willing to pay for that 17.5 millionth worker is 17.15, which happens to be equal to the market wage, right? Now, the marginal employee is the last employee hired. And the marginal employee is hired by the marginal firm. The marginal employee is the person, right, who gets no surplus, no employee surplus or worker surplus if they accept the job, because the lowest wage that last person is willing to accept is the height of the green curve at this quantity of employment, right? And that is 17.15. So the employer surplus that accrues to the marginal employer, the marginal firm, for hiring the marginal employee, that worker surplus for that marginal employee is that the employer surplus, the firm surplus, is zero, because that marginal firm is going to hire that last marginal worker a wage that is equal to the market wage. And the same thing goes for the marginal employee. The marginal employee is the last worker hired. Their reservation wage is 17.15, which is the market wage. So the marginal firm and the marginal employee, for that last hire, the worker surplus and employer surplus are zero, right? Now, that's not the case for the first employee, right? The first employee hired, the firms value them at $21. That first employee, or those first group of employees hired, firms value them at $21 an hour, right? This person down here that has a reservation of 3.5, right? If they're lucky enough to be hired, their surplus is massive, because they'd be willing to do the job for $350, and then they get paid $17.15 for it, right? So the worker surplus is nearly $14 for this most desperate of workers, the one that has a reservation of 3.5. That first worker hired by the firm only has to pay them $17.15, but they would have been willing to pay that person $21, right? So the firm derives almost $4 in firm surplus from hiring that first worker, because they would be willing to pay up to $21 for that first worker, but yet only have to pay $17.15, right? Now, these individual surpluses, they decline as you get closer and closer and closer to the equilibrium, right? For the firms, labor is getting less scarce, right? So as something gets less scarce, they're willing to pay less and less for it. That's one way to think about labor demand. Another way to think about labor demand is you have this job that you want to hire for. You have these positions to fill. You get a flood of applicants. And when you review the applicants, you put them in a queue from the most valuable to the least valuable, right? And the most valuable employee to the firm is going to be at this point, right? They have the best resume. They have the best cover letter. They have the best mix of skills, training, and education, right? Experience. So you're going to value them the most. The person over here, this person here, that person right there is the 25th in line, right? The 25th in line. And the firm only values that person at $15.49 per hour. Why? Well, maybe their training is not as good as they've seen among the applicants, or their experience is not as great, or their education is not as great, right? So you put lower value on them. So you can think of the labor demand curve as a queue where you order the most valuable employee. They're the number one person you want to hire. And you put them in order according to this value that you perceive from their application materials to the last applicant, right? So that's another way to look at the labor demand curve. The labor supply curve, on the other hand, is really just a queue of workers who have different reservation wages, right? The very first employee is going to have a low reservation wage, right, in the queue. So this person might have a bunch of kids, not very good education, experience, not very experienced. Training is not very, highly sought after. So this person might be really desperate to get a job, and so they'd be willing to do a job for $350. And then if we order people from the lowest reservation wage to the highest reservation wage, right, we generate the labor supply equation, right? Okay, now with all that said, let's go through the problem here and analyze the effects of a subsidy, right? So politicians wishing to increase self-reliance and independence among low-skilled workers who are enrolled in public assistance programs say they enact a wage subsidy that is paid to employers. So it's going to be paid to the employers, right? The employers are going to be hired, or the employers are going to be compensated by government if they hire a person that meets these requirements, right? So they're going to receive a wage subsidy. The people who hire these public assistance participants, they're going to be paid a subsidy, right, in the form of an end-of-year tax credit. An employer participating in the program must submit evidence of hiring such individuals, right? Individuals eligible for the program. The taxes withheld and the hours they worked, right? Okay. If the subsidy, suppose you're an economist and you've estimated the labor demand equation and you've estimated this labor supply equation for this particular labor market, and you've observed a 21% increase in low-skilled laborers being hired in this labor market, right? First, you can calculate the new employment level, right? Because the original employment level was 17.5, correct? So we need to increase 17.5 by this 21% because that's what you've observed, right? So let's open up another Desmos for calculations. Okay, so the original employment level is 17.5, right? This program you've observed has increased employment level by 21% in this labor market, right? So we're going to multiply that by 0.21, 21%, right? So the increase in employment in this labor market is 3.675, right? That's the increase. So the original employment level is 17.5, right? The increase in the employment level is 3.675. In order to get the final employment level, we have to add the initial to this increase, right? So this is the initial employment level. This is the increase. When we add those two together, we get the final employment level in this labor market, which is 21.175, right? And again, this could be in millions of, whoops. you got to be really careful with my math here, bouncing back and forth. So the initial employment level is 17.5, right? And the final employment level is 21.175. Right? You've observed that, right? So this, if you drop straight down, you get to 17.5 here, right? At 21.175, we're at this dashed line here. Okay, so the employment level increased from this level out to here, right? To 21.175, right? Now we're going to substitute this value into our labor supply equation, right? We're going to substitute that in the labor supply equation. So when you plug this 21.175 into our labor supply equation, we should get a number that's between 18 and 24, right? It's the reservation wage of the new marginal employee, right? We've drawn somebody into this labor market that has a higher reservation wage than the previous, right? The previous reservation wage at the equilibrium was 17.15, right? The marginal employee initially had a reservation wage of 17.15, right? The last employee drawn into this market by the subsidy has a reservation wage somewhere between 18 and 24, closer to 18, right? Than 24, right? So 19 something, maybe 20 something, maybe it's between 19 and 20, right? So we're going to plug this 21.175 into the labor supply equation, right? So I'm going to copy the labor supply equation right to here. And I'm going to define this thing in row 1 as the employment level, right? So the final employment level is 21.175. Excel plugs that, replaces the E with what it equals, right? Multiplies this 21.175 times 0.78, then adds that to 3.5, and you get 20.02 if we round to 2 decimal places, right? So the reservation wage of this new last employee hired, right? The last participant of this government subsidy program, that last person's reservation wage is $20.02 per hour, right? Notice what my math does. It bends that dashed line. Once this dashed line hits the labor supply curve, it bends that dashed line at that last participant in this government subsidy program at that person's reservation wage, right? Which is $20.02. Now what we want to do is we want to substitute this new employment level, right, that we calculated, that we observed. We're going to plug that into the labor demand equation, right? So I'm going to copy the labor demand equation here. And when I paste it into Desmos, what happens is Desmos replaces E with this 21.175, and we get the highest wage firms are willing to pay that person in this government subsidy program. It's what the maximum they're willing to pay. Now, the difference in these two values is the amount of the subsidy that must have been paid, right? The difference between the wage rates above gives the hourly wage subsidy that is needed to boost employment by 21%, right? So we're just going to subtract the two here. 20.02 minus 16.34. And we get 368. So government is giving the firms $3.68 for every hour an employee in the program is worked, right? They give them $3.68 per hour, right? So that's the height of these two dashed lines, right? That's the height of these two dashed lines. And notice that the labor demand curve shifted out to the light blue line, right? It shifted out, right? Labor demand increased. So when you subsidize something, you get more of it, right? So labor demand was low, now labor demand's high, right? Labor demand increased as a result of the subsidy. So what we can do here is we can take our tax subsidy model here. I'm going to turn this off down here. See, turn that off down there. I'm going to go down here to my tax subsidy model, and we're going to give the subsidy to the demanders. The demanders of labor are the firms. So we're going to give them the subsidy, 3.68. Okay. So the current demand curve is the red line, right? And the past demand curve is the black line. And we can see that demand increased, right? If I turn this back on, I can turn off there we go. I can turn off and turn on the surplus, right? This is the worker surplus, right? And this is the firm surplus, correct? Initially, when this was 0, the firm surplus is the area under their labor demand curve, right? Between the labor demand curve and this market wage, right? Whereas the worker surplus is this pink triangle, right? When we set the subsidy equal to 3.68 and we give that to the employer, that shifts the labor demand curve out to this red line. We have a new market wage, right? The new market wage is just above $20.02, right? In my model. If I click on this, here, the worker is being paid, right? The worker is receiving $20.02, right? Each worker is receiving $20.02 now, right? Because that's where supply and demand meet, right? They meet at this point here. So the wage that is being offered is $20.02, right? So worker surplus increases, right? From this pink triangle to this pink triangle, right? Because each worker is being paid $20.02, correct? Right? So this very first worker, right, hired, they've been willing to do the job for $3.50. They're getting paid $20.02, right? The previous marginal employee, right, their reservation wage was $17.15, right? And initially, they had no surplus, so they were indifferent between working and not working. But now they're most definitely interested in what? Right? They're making $20.02 an hour. They were making $17.15 an hour, right? So after the subsidy program is put in place, they're now making $20.02, and they would have done the job for $17.15, right? The new marginal worker, on the other hand, the new marginal worker has a reservation wage of $20.02, and that's the wage they're being paid, right? So the new marginal worker has zero surplus, right? Zero surplus. Okay. So that's the worker surplus. Okay. What about the firm surplus? The firm surplus is this blue triangle, right? Initially. But when firms are given the subsidy, right? When firms are given the subsidy, right? They can pay workers the $2.20, the $20.02, but out of pocket, they're really only spending $16.34 per hour, right? Because the subsidy is $3.68, right? So out of pocket, right? Out of pocket, they're only spending $16.34 because government is paying them this difference here, right? The vertical height difference here is the amount of the subsidy, right? And so firm surplus increased from this blue triangle here. It increased from this blue triangle initially, right? It increases from this blue triangle to this blue triangle, right? The most they'd be willing to pay that 21.18 employee is $16.34, right? The market wage was only initially the market wage was only $17.15, right? So initially they didn't hire anybody along. They didn't hire anybody with these valuations, right here, right? They didn't hire anybody here, but they're now hiring this person. Why? Because the government's giving them $3.68 to hire this worker that they only value at $16.34, right? So this worker here is hired because the company, although the company's only values their labor at $16.34, the government gives them the difference in these two, right? It gives them the subsidy of $3.68, so they go ahead and hire that last person, right? That last person that participates in this employment subsidy program that's run by government, right? Okay, so clicking the submit button after you enter a number in the above answer box will demonstrate the effect of subsidy on employers and workers, right? And it increases, if we go horizontally, it increases labor demand, right? So if we hold wages at this dashed line here, employment goes from over 20 to nearly 40, right? So that's an increase in labor demand. Increases low-skilled labor demand, right? The cost of this program equals what? The cost of this program is this box here, right? Let's go ahead and hit enter here. I'm going to submit these two answers. Okay, the cost of the program we want to calculate now. The total cost of this program on an hourly basis is this red box, right? The height of this red box is the amount of the subsidy. The width of this red box is the new employment level, right? So we have this new employment level, 21.175. This is 0. So the width of this box is 21.175 minus 0, right? So the length of this box is the 21.175, the number of employees that are in the labor market after the subsidy is put in place. And the height of this box is the amount of the subsidy, right? And the subsidy is 368. So what we have to do here, we have to calculate, right? The cost of the program is what? The $3.68 per hour subsidy times the new employment level, right? The new employment level is 21.175. So per hour, the cost of this program is $77.92. Now, if this is in millions, this is in millions, right? So, I mean, just think about this. If this is actually in millions, right? How expensive this program per hour, right? It's a pretty expensive program per hour, right? But that's just per hour. How many hours does each employee work each year? Well, each employee, if they're full-time, are going to work 40 hours per week. If they have 2 weeks vacation, that's 2,000 hours a year, right? So if we multiply this by 2,000, we get the cost of the program, right? It's quite high, right? We got 11 zeros here, right? So we got 155,848. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is a really expensive program, isn't it? This is millions. This is billions. So this program would be really expensive to the American taxpayer. It'd be $1.56 billion, right? If there are 21.175 million low-skilled laborers, right? And we give them, the government gives the employers $3.68 per hour per employee, right? The cost of that program is $156 billion a year, right? So we're not talking about peanuts here, right? We're talking about a lot of money. We'll just go back to the hourly cost, right? So it's $77.92 per hour, right? And again, this is millions, if we're talking about millions of low-skilled workers, right? So $77.924 per hour. Oh, I need to make this 2 decimal places, right? Dollar values are in 2 decimal places. So there, this red rectangle is $77.93, right? Now, what we want to do is we want to calculate how much the employer gets versus how much the employee gets, right? Because that's important, right? We want to know how much the employee benefits versus the employer, right? We always want to look at who benefits the most from this program, correct? Now we're talking about low-skilled laborers, right? Low-skilled laborers are probably going to have pretty inelastic supply. Why? Because there's not as many options for them. I mean, for example, LeBron James can work at a Walmart. LeBron James can work at a Goodyear tire store. But LeBron James can also make, $1 billion playing NBA basketball, right? So LeBron just got a lot more options because he has incredible physical gifts, and which includes height, size, muscle, speed, and jumping ability, right? He has a rare combination of those things, which are highly valued by owners of basketball teams, right? So LeBron James, he's a different kind of cat, right? As opposed to me and you. If we didn't have college degrees, what are our options? All we can do is maybe work at a Walmart or a Walgreens or a gas station, right? If we didn't have any education, right? But LeBron has all these incredible gifts. So he has more options, right? When you have very few options, and you don't have a very high skill level because you don't have very much education or you don't have a lot of experience, and you want to put food on the table and you want to pay your rent, well, you have to be insensitive to increases in the wage rates, right? So that makes your labor supply inelastic, right? Okay, so the difference in the market wage and this W max, right? The W max, if you remember, the W max is the maximum wage in the absence of the subsidy, the maximum wage firms would pay this last participant of this labor subsidy program, right? That's the maximum wage. So we're going to take the difference of this value here, the market wage, right? We're going to take the market wage, which is $17.15, the initial market wage, which is $17.15. We're going to subtract from it the maximum wage firms are willing to pay that last worker hired in this wage subsidy program, right? Which is 21.175. Or sorry, 1634, right? We're going to take the difference of these two. The difference of those two, 1715 being the initial market wage, minus the maximum wage firms will hire this last worker, right? Which is 1634. So 1634 is the value, how much they value the hourly productivity of that last worker hired in the subsidy program, right? So that difference is 0.81, right? When I press enter, notice what happens, right? This red box here is the part of the subsidy. Now, remember, the subsidy was given to the firms, right? The subsidy was given to the firms. But the firms don't receive much of the benefit of that subsidy, right? They receive very little of that subsidy. This is the total value of the subsidy that they pocket after the additional workers are hired at that new wage of $20.02, right? So this is how much they pocket of that subsidy, right? In total, right? Each hour they pocket 81 cents, right? But when, and then when you multiply it by the number of laborers, right, at this new equilibrium here, When you multiply that by the number of laborers, which is 21.175, the benefit to them is only 17.15. Now that's in millions of dollars, right? So that's not chump change, right? If we have millions of, if this is in millions of employees, then this is $17.15 million, right? That's not chump change, right? So multiplying this 0.81 by the number of people employed after the subsidy is enacted gives the hourly benefits of the subsidy that accrue to the employers in this market, right? And it's $17.15 million if there are 21.175 million employees in this labor market, right? Okay. Now we want to calculate the benefits that accrue to the workers, right? We want to accrue the benefits that accrue to the workers. The workers were being paid $17.15 an hour, right? Initially. But the subsidy resulted in then their pay rising to $20.20, right? They're actually receiving $20.20, right? Initially, they were only receiving $17.15, right? So the height of this box is the amount of the subsidy they receive, right? It's their share. The firms get this share, right? Workers get this box that's created by these dashed lines and this top red line, right? So let's calculate the benefit that accrues to the workers. So the difference in the reservation wage, which is 2020, right? The reservation wage is $20.20 in my model, right? $20.20 or $20.02, right? So $20.02 is the new wage that the workers are being paid minus the initial equilibrium wage, which is $17.15, right? So initially, again, they're being paid $17.15. Now they're being paid after the subsidy is paid to the employers. They're being paid a total of $20.02 an hour, right? So on a per hour basis, each employee receives, right? Each employee receives $2.87. Now that's $2.87 plus it's 81 cents equals the subsidy, right? This is the subsidy the employer receives for hiring these workers, right? In this program. They receive this $3.68 per hour for each employee they hire, right? And if we're talking about 2,000 hours a year per employee, and we're talking about millions of employees, that was like $1.56 billion, right? A little bit of it goes to the employer, right? Most of it goes to the employees, right, in this market. So now we got to multiply this 287 by this new employment level, right? And when I multiply the subsidy, the per hour subsidy that goes to each employee by the number of laborers that are now in the market, I get a total hourly benefit to these employees of 60.77, right? Now, again, that's not chump change. Again, that's not chump change, right? Because if this is millions of employees, right? This is millions of dollars, $60.77 million. Now, another way to get this is if I subtract the 17.15, if I subtract that from this, I'll get the 60.77, right? This plus that equals that, right? Just like this plus that equals the subsidy per hour, right? So you can see the benefit to the employees is much bigger than the benefit to the employers. The benefit to the employers is this little box right below the red box, right? It's a little sliver compared to the benefits to the employees, right? So this program might be judged useful if the amount of the subsidy is less expensive to the government than is the public assistance that these employees were receiving initially, right? So the government want to shift them from public assistance and no work to essentially public assistance and a work, right? So this program, if this red box is smaller than the direct assistance that they were paying these low skilled workers who weren't working before, if this red box is smaller than what they were giving these low skilled workers who were not working initially, right, then the program might be considered a success, right? If this program encouraged work and was cheaper than public assistance without work, then it'd be even more of a success, right? If these workers eventually become self-reliant and independent, if they continue to work, they're going to build job skills. They're going to move up within the company, and they'll get their income will get to a point where they won't need the subsidy anymore, right? They'll be beyond the subsidy. They'll be self-reliant. If this jobs program, this subsidy program, is not implemented and people are kept in public assistance with no requirement to work or no encouragement to work, then the people might not eventually find work and become self-reliant, right? They become dependent on the state. So that's very costly over the long run. Maybe as a way to get them off state assistance where no work is required, we can convert the program into a subsidy that encourages them to work. And if they do work in the program and they build sufficient skills, eventually their incomes are going to be high enough where they're going to be highly valued by other firms, and they'll get jobs with other firms, and they'll no longer need any kind of assistance, right? So if we're going to have a public assistance program, maybe perhaps this is the best one we should adopt, right? Okay, the subsidy is directly paid to firms, and the benefits that accrue to them are less than that of the employees in this labor market. And we know that because the box below this red box that is formed by this dashed line and includes everything up to this red line, those are the benefits that accrue to the firms, right? Whereas this red box are the benefits that accrue to the employees. So although the firms are given the money, right, the employees, the benefits that accrue to them are less than the benefits that accrue to their employees, right? The cost of this program per additional worker, per additional labor, the cost of this program per additional laborer added equals what? What do I mean by that? The cost of this program per additional worker added. How many workers were added to the labor market, right? That's what I'm asking. Right here, right? We're going to take the cost of the program, which we've already calculated, 77.93. The cost of this program, we're going to divide that by the workers that were drawn into the labor market, right? And the workers that were drawn into the labor market equal what? Well, the number of workers that are in the labor market as a result of the subsidy is 21.175. But the number of workers that were in the labor market before the subsidy was 17.5, right? So remember, it drew in 3.675, right? This amount is 3.675, right? So the number of workers initially in the program was only 17.5, right? The number of workers in the program, or the number of workers in the labor market after the program was instituted is 21.175. So how many workers were added to the labor market? 3.675. Now that's not chump change again, remember? If this is in millions of workers, we're talking about 3.675 million workers, right? So that's not chump change. That's a lot of human beings, right? Okay, so what I'm asking for here is the cost of this program per laborer, not the 21.175, but the laborers that were added as a result of the program, right? That's how you really want to calculate this cost, right? It's not the cost per laborer in the labor market. It's the cost of the program per the additional laborer in the program, because the program was intended to draw people into the labor market, right? So we're going to divide the benefit, right? The total benefit of this program. We're going to divide that by this 3.675, right? The 3.675 are the additional workers, the workers that were pulled from public assistance where work wasn't required into the subsidy program where their labor is subsidized, right? So that builds self-reliance. The cost of the program is $77.93. And again, that's in millions of dollars if we're talking about millions of employees. This is the increase in employment in the labor market as a result of the subsidy. And that subsidy cost $77.93 million. The millions cancel, right? The millions cancel. And we get $21.21. The cost of this program per additional labor added equals 21.21, right? It's the cost of the program divided by the additional laborers in the labor market, right? 21.21. This number here, you want to round this to two decimal places, and then that value equates to an annual cost of what? Who works 2,000 hours, right? So we're going to multiply this by 2,000 hours. And we get $42,410. $42,410. So if this program increases employment by 3.675 million workers, and the program costs $77.93 million, the cost of this program per worker, right? If they all work full-time, 2,000 hours a year, the cost of this program is $42,410.88 per year. That's a lot of money, right? Is it worth it? Right? That's a lot of money. So now this isn't what each worker is receiving, right? This is just the cost per year to the federal government per employee if all of those additional workers are working $2,000 or 2,000 hours a year, right? That's a pretty expensive program, right? The subsidy induces a deadweight loss that results from the total cost of the subsidy to the government being greater than the surplus gained by employees and employers, right? Before the subsidy, employer surplus was what? We need to calculate the employer surplus and employee surplus before the subsidy was created, right? So let's go back here. We'll reset the subsidy to the employer to 0. Right? Now we need to calculate the firm surplus, right? The firm surplus is this blue triangle here, right? And this triangle is determined by these points here, right? So the height of the triangle is the difference between 21 and 17.15. The 21 is the intercept of our demand equation, right? 21, right? And the 17.15 is the initial equilibrium, right? Wage, the initial equilibrium wage. So we got this, right? This difference here is the height of the triangle, right? So let me go to my work here. So the height of the triangle is the 21, right? 21 is my labor demand intercept. We're going to subtract off that the initial market wage of 17.15, right? And then the width of this triangle With this triangle is the 17.15, yeah, the 17.5 million workers, right? So this is 0, right? 0. And this employment level is 17.5. So 17.5 minus 0 is 17.5, right? So we're going to multiply the height of the triangle by the width of the triangle, which is 17.15 or 17.5, right? That gives us a rectangle. That would give us the area of this rectangle here, right? And the area of this triangle is half of that rectangle. So we had to divide that by 2 to get the original firm surplus, right? So the area of this blue triangle is 33.69. Again, that's per hour, right? Per hour. Okay, what about the employee surplus? Let's go back here. The initial employee surplus, I'm going to turn off the employer surplus, and I'm going to turn on the employee surplus. The worker surplus is determined by this triangle, right? So these numbers are the same as before, but this number down here is the intercept of labor supply, 3.5, right? So let's go back over here to Desmos. From that market wage, right? From the right here, here's our triangle here, right? Our market wage is 17.15, right? Our market wage is initially 17.15. And we go down here to the intercept, which is 3.5, right? So I'm going to take 17.15 and I'm going to subtract off the intercept in my model, right? 3.5. That's this value right here, right? That's 3.5. This is the original equilibrium, 17.15, right? And the width of this triangle, again, is the initial equilibrium number of employees hired, right? 17.5. Now, if we don't divide by 2, we get the area of a rectangle here, right? So we only want half that area. A triangle is half a rectangle. So we divide by 2. And we get a worker surplus of $119.44. Okay, so and the total surplus initially is what? The total surplus initially is this blue triangle plus this green triangle. So let's go back to our model here. I'll turn. So I want the blue area plus the red area, right? So I'm going to add them together here, right? So the firm surplus, the blue area of my triangle, is 33.69 plus 119.44, right? And I get a total surplus initially of 153.13, right? Okay. Now, after the subsidy, employer surplus is what? Okay, so the labor demand curve shifts from black to this light blue line, right? Creating a new equilibrium quantity. That last worker hired in the subsidy program is not worth much to the firms, right? They're willing to pay that worker, that last worker hired in the program, just $16.34 an hour, right? So firm surplus does increase, right? It increases from the smaller triangle to the slightly bigger blue triangle, right? And so the height of this triangle is, again, the intercept of the labor demand curve, right? The intercept of the labor demand curve minus this, the maximum wage they're willing to pay that last employee that's in the program. And that was 1634, right? So the height of this blue triangle is 4.66. This is the intercept, 21 again, right? This value right here, this height is 21, the intercept of labor demand, the initial labor demand, right? And this height here is how much they're willing to pay the new last worker hired, right? The last worker in the program that was hired. And they're only willing to pay that guy 1634, right? So that's the height of this triangle, right? That's what this is. Now we're going to multiply that by the new employment level, right? The new employment level is 21.175, right? That makes a rectangle. That's the area of this rectangle, right? That'd be the area of this rectangle. The triangle's half that area. We want only half of that. Right? We don't want the whole rectangle. We want half the rectangle, right? So we have to divide this by 2. So the firm surplus after the subsidies put in place is 49.34, right? 49.34. Now we need to calculate the employee surplus, right? So let's go ahead and do that here. Let's do it graphically here. Let's turn off the worker surplus. Let's add the subsidy paid to the firms, right, per hour. The subsidy per hour to the firms is 368, right? So this blue triangle is bigger than it was, right? It was here, right? It is now a little bit bigger, isn't it? A little bit bigger, right? A little bit by this quadrilateral down here, right? This quadrilateral down here represents the increase in firm surplus, right? Okay, so now let's calculate the new employee surplus, right? Let's turn off the employer surplus and turn on the employee surplus. Okay, initially the employee surplus was this red triangle, right? But the firms are paid this per hour subsidy of 368, right? So although firms are willing to pay at most 1634 for this last worker hired, they'll hire them because government's going to pay the difference between these two, right? Government's paying the difference of these two. So although the firms only value them at 1634, right? The firms are going to pay and hire this worker because the government's going to cover the last 368, right? Firms pay the first 1634 of the hourly wage, right? Government pays the last $3.68, right? So that last worker gets hired, correct? That increases the worker surplus by the trapezoid that's between this dashed line here and this dotted line here, right? Down the labor supply curve. That's how much worker surplus increases by. Because this was the original market wage, right? This point here, the original market wage was $17.15, and the original employment level is 17.5, right? Now, the wage that's paid to the employee is $20.22, and 21.18 employees are hired, right? So this trapezoid up here, created by these 4 points, that's the increase to worker surplus, right? So to calculate the new employee surplus, we have to calculate the area of this triangle here. Okay, the height of this triangle is the difference in the intercept of supply and the new market wage, right? So it's the difference between the 3.5, right? 3.5 is the intercept of labor supply and this new market equilibrium, right? The intersection of the new demand curve and the original supply curve, right? And that was $20.02, right? So we're going to subtract $20.02 we're going to subtract 3.5 from $20.02, right? So we're going to subtract the intercept 3.5, right, from this value, right, which is, in my case, $20.02. So my intercept is 3.5, right? So that's the height of this triangle here, right? $20.02 is the reservation wage of this last worker hired. 3.5 is the intercept of my labor supply equation. So I'm going to take their difference. Then I'm going to multiply by what? I'm going to multiply by the number of employees in this labor market, which is 21.175 in my model, right? That'll give me the area of a rectangle, right? That comes all the way over to here. But I want the area of the triangle. So I got to divide the area of the rectangle by 2, which is why I'm dividing by 2 here, right? And I get a new worker surplus of 174.91. Okay. Now the new total surplus, notice there's an overlap here, right? I got to add this green, the area of the green triangle. I got to add that to the area of the blue triangle, right? There's an overlap, isn't there, right? There's an overlap between the two now, right? So I got to add the green triangle to the blue triangles area, right? So the new total surplus is the 49.34. That is the new employer surplus, right? I got to add that to the new employee surplus of 174.91. And I get new total surplus of 224.25. Right, that's the new total surplus, right? The new total surplus. Okay, let's go back to here. So if I turn on the employer surplus, right, I had this overlap, right? I have this pink triangle, and then I have this blue triangle, right? You can see part of it here, and you can see part of it there, but then the intersection of the pink and the blue is this purple region, right? That's the overlap, right? The intersection. Okay. So the increase in total surplus is this funky thing here, right? This right here is the increase in total surplus. Okay. It's along this dashed line down the labor supply curve, and then down the labor demand curve, and then back over to the wage axis or the y-axis, right? And straight up, right? That is the increase in total surplus. Okay. The overlap, right? If you will, right? Okay, so we got to calculate that area, right? Now, how do we calculate that area? Well, all we're going to do is we're going to take the old total surplus and subtract it from the new total surplus, right? So the old total surplus was 153.13, right? The new total surplus is 224.25, right? So the increase in total surplus is 71.12, right? That is this area here, right? That's the increase in total surplus. Okay. Now we're going to subtract this increase in total surplus from the cost of the program. The cost of the program, if you remember, was 77.93. So the cost of the program is 77.93. We're going to subtract from that the increase in total surplus, which is 71.12, right? That gives us the deadweight loss. And the deadweight loss is this red triangle, right? So if you look to the left of this red triangle, you got this white rectangle here, right? That white rectangle, well, not white rectangle, but this white shape, right, with this indentation in it. So if we start here, we go down this dashed line, and we slide down the labor supply curve, and then slide down the labor demand curve, and then come back to the y-axis on the dashed line, we have this white shape in here, right? That looks like it has 1, 2 teeth, right? That's the increase in total surplus. Now, if you go down the dashed line and over to this red down line, and then back over to the y-axis along this dashed line and then up, you get the total cost of the program, right? The total cost of the program is this rectangle, right? If you subtract this red triangle from this rectangle, you get the increase in total surplus, which is a weird looking shape, right? It's a 5-sided shape. 1, 2, 3, 4, 5. This five-sided shape, right? That is the increase in total surplus. The rectangle is the cost of the program, right? And their difference is what we call deadweight loss, right? Deadweight loss. And the deadweight loss is 66.81. Now, instead, suppose the subsidy is given directly to the public assistance program participants who are presently not working and possess skills that are not highly valued by employers. With the intent of increasing self-reliance and independence among these individuals, program participants are advised by their caseworkers that they can receive the wage subsidy in monthly payments provided they submit paperwork each month as evidence of working for income and payroll tax withholding employers. If you're working for income and for payroll tax withholding employers, right? If the program increases the number of low-skilled laborers by 21%, so we're increasing employment by 21%, we're increasing employment by 3.675, right? Employment was 17.5. It increases by 3.675 to what? It increases to 21.175, so the same amount, right? Now, when we calculate this new employment level, 21.75, and we set it equal to E, Desmos, if you remember, will replace the E with this value, and it comes up with $20.20, right? Rounded 2 decimal places. It does the same thing in the labor demand equation, right? 1634, right? And so the subsidy, again, is the difference in these two. So the amount of subsidy doesn't change, right? If you want to increase employment by 21% by giving a subsidy to employers, the subsidy in this model has to be 368, right? If you want to increase employment by 21% by giving a subsidy to public assistance program participants, right? In this model, the subsidy has to be $3.68, right? Okay, so in this situation, right, where the subsidy is being given directly to the workers, to their case workers, right, it shifts labor supply to the right, right? Labor supply is shifted to the right, which is an increase in labor supply, right? Because if we hold the wage constant at 24, right, and we go from this level of employment, which is about 26, well, it will increase quantity of labor supplied to like 31 or 32, right? So that's an increase in labor supply. The benefits of the subsidy accrued to both workers and firms are not contingent on the side that receives the subsidy. Rather, it is determined by the elasticity of demand and supply, right? So we're going to compute the wage elasticity of labor demand and labor supply at the original market outcome. So let's go back here, right? So in order to calculate the wage elasticity, remember the wage elasticity Wage elasticity of demand or wage elasticity of labor supply, it's the percent change in quantity over the percent change in the price, right? In labor economics, quantity is employment level and the price is the wage rate, right? So one way to calculate this is to calculate, as I explained previously, is at a point, right? At a point like the initial equilibrium point, we can do the change in employment over the change in the wage, right? We can multiply that by the wage employment ratio. So this divided by, whoops, this should be employment. This change in employment divided by E is a percent change. And this, the inverse of this divided by W is a percent change in wages. This right here is the slope of the line. And this is just the wage employment ratio, right? So if you look at our labor demand curve, we're going to do the elasticity of labor demand first. If you look at our labor demand curve, this is the change in W over the change in E, right? So a negative 0.22, that's the change in wage over the change in employment. We want the change in employment over the change in the wage. So what we're going to do is we're going to divide this. We're going to take the inverse of it, right? So now when we take the inverse of our slope, we get the change in employment over the change in wage, right? And then all we got to do is multiply that by the wage employment level ratio at the initial equilibrium, right? And at the initial equilibrium, the wage rate was 17.15, right? The market wage was 17.15, and the initial employment level was 17.5 million, right? And we get an elasticity of negative 4.45. Okay, now we got to do the same for labor supply, right? We got to do the same for labor supply. The only thing we got to do is change the slope, right? The slope is 0.78 instead of 0.22, right? But it's also positive, 0.78. This is, again, this is the change in the wage rate divided by the change in employment. We want the change in employment divided by the change in wage rate. So that's why we take the inverse of it, right? And then we multiply it by the wage employment level ratio, right? And we get an elasticity of 1.26. 1.26. Okay, so both labor demand and labor supply at the equilibrium are elastic. The wage elasticity of labor demand and the wage elasticity of labor supply at the equilibrium in absolute value are greater than 1. So both at this equilibrium point are elastic, right? Demand is elastic at the equilibrium, the initial equilibrium. Labor supply is elastic at the initial equilibrium, right? But the wage elasticity of labor supply in absolute value is closer to being in between 0 and 1. When elasticity is between 0 and 1, we say whatever that is, it's inelastic. When you're inside 0 and 1, that thing is inelastic, right? So we're closer to 1.26 is closer to being inside of 0.1 than is 4.45. So what we can say is, since labor supply is relatively more inelastic, since labor supply is relatively more inelastic, right? Employees benefit more from the subsidy, right?